Hi class, welcome back to Geography 103 in the time of COVID. And we've reached pretty much the end of the semester. And I was reading our text and sitting out here by this beautiful river and with my dog who keeps looking for mostly golf balls. And we were coming up with a good project for your final assignment. And a lot of you did a really great job with the hydrograph section, and I thought we'd look at streams and landscape processes a little more, because one of the promises in this class was to explain things like why the sky is blue and why the world looks the way it does around you. And a big part of it, pretty much no matter where you are stream processes, and especially stream processes combined with uplift processes. Like I think one of our last lectures we were looking at endogenic processes within the earth, basically volcanoes and plates moving and crashing into each other, and these big processes that lift parts of the planet up. And then the sculptor comes in, and this is rainfall and stream flow. And you can see in this landscape behind me is a huge cliff, and the YouTube resolution probably isn't going to be good enough, but there are layers of rocks over there. And I can see that was once laid down when everything was pretty much at sea level or flat, and has since been lifted up. And that's true of all over this part of Canada. It used to be covered in a giant ice sheet, and since the ice sheets have receded, the landscape is like has a buoyancy next to the mantle, and it's rising up. It's pretty cool. And all this goes under what we think of and how we understand the way the world works through Davisian geomorphology. And you might think I misspoke, but Davisian geomorphology is named after a guy whose name is William Morris Davis, and he was following the sort of the profound impact of Charles Darwin's on the origin of the species and evolution. He's like, hey, wait a second, this applies to landscapes. I can tell if a landscape is new or middle-aged or old, and I can do this because a new piece of a landscape would be something like a volcano, something that has recently emerged from within, and then as time goes on, these new beginnings get eroded away and will eventually become flat land. And you can see this in your text. If you turn to page 514 is where they talk about William Morris Davis and the geomorphic cycle. And here is essentially the idea: uplift, and then the streams start to cut everything away, and then you have a really divided landscape, and then a late mature, and then to an old age landscape where it's really flat, but it's at base level flat. So that one's flat, but it just uplifted, and then it erodes it all the way down. And one thing I like to realize when I'm looking at rivers and appreciating them is the work that they do. Like, this is constant, its only job in life, and its constant effort is to erode the landscape all around it and transport it to the sea. It's going to make the whole world flat. That's really the ultimate goal of rivers. And in the process of doing so, they create beautiful shapes. They create the terrain that we live on. And if I were to assess whether this is an old or a young landscape, I would say, well, this is a pretty old landscape, but I have a lot of forces at play. And this is what I want you to do for your final assignment for me. And I'd like it to count more than your final exam, which is going to be hard to make comprehensive, and I'm going to make it pretty short, basically focused on the first half of the class. And if you do well on this assignment, I would say don't take it. You can opt not to take it if you're happy with your grade up to that point. But what I'd like you to do is select an area. It could be close to your house, or it could be something like the Grand Canyon, and you're going to give me 2 pages discussing what factors created that landscape as we see it today. And I would really like you to frame it in terms of Davisian geomorphology, and I'll explain a little more. So in a really old landscape will be incredibly flat, and it's just been worn down by stream processes over thousands of years, and it creates what's called a peneplain. So let's say this is our peneplain, and then if you create uplift from below and you start to generate a real piece of elevation, you start to create a young landscape, and this, we'll call that our young landscape. Hopefully you can see all that. And then as time goes on, you're going to have rain events that slowly melt away that part of the landscape. And then it's gradually bringing it down to a really flat form. And that, in sand beside the Credit River in southern Ontario, is the basics of the Davisian geomorphic evolution. And what I'd like you to do is pick a landscape. If I were you, I would choose something close to your house and give me an idea of whether it's old, if it's young, and the forces involved basically out of your textbook that contributed to make it look like it does today. And a lot of it is going to be streams. And if you choose something by the bay, you might be looking at coastal processes. This is another big one that we have in geomorphology. Or if you're here in southern Ontario, it could be dog-related erosion processes as your dog digs holes. But it could also be glacial processes. There's some serious glacial processes here in southern Ontario, and also even in the lower 48 in our in the Colorado Rockies and our more northern rocky chain, I guess. And then there's also aeolian processes that you don't want to forget about. And this is landscape shaped by wind. And very few of these are act by themselves. Usually you're going to find that it's an accumulation of a lot of different factors that will shape a landscape. So I'd like you to put that into your write-up for me. And I'd like 2 pages, double spaced, and I would include a picture if you would, so I know where you're talking about. And again, what I'd like you to do is tell me how that landscape was formed based on some geomorphic principles. And if you're curious, like, hey, wait a second, we missed this part of class, it's all in your textbook. And the basics is you have uplift, and then you have erosion, primarily caused by precipitation and weathering and runoff. And then there's some other factors like aeolian processes, wind-driven processes. You can think of sand dunes, coastal processes if you're looking at, like, let's say the Outer Banks of Virginia or North Carolina. Yeah, and then there's sort of isostatic or glacial processes that you might see up here. But by and large, you're going to see mostly uplift and erosion processes. And finally, when you're sort of concluding your 2-page paper, I'd like you to mention how old you think the landscape is. Is it a really old landscape in the Davisian geomorphic cycle, or is it a fairly recent landscape? Okay, guys, I again am so sorry that we didn't get to have this class in person. It was a real drag for me. I love teaching 103, and I get a lot of students out into the field, and I'm really sorry that we didn't get to do that this year. And I hope it doesn't affect your love for earth science or really the planet around you. And we're lucky enough in earth sciences to get to study these cool processes. And I hope you gained something through the course of our very unusual semester. And it was a real pleasure having all of you. Thanks for the laughs and for the fun sharing of information. Okay, guys, I'll miss you, and I'll see you sometime in the future. Bye.